This hack tip is brought to you by HipChat. Welcome to HakTip, the show where we break down concepts, tools, and techniques for hackers, gurus, and IT ninjas. I'm Shannon Morris, and today we are checking out Wireshark and DNS. Woohoo! So first off, DNS. That means Domain Name System. It's the reason why you type in a website like google.com and it goes to google.com's IP address. So it makes it work. Now this way you don't have to memorize a whole bunch of different numbers to take you wherever you want to go on the entire interwebs. So to view all the different types of DNS traffic you might run into, go over to the site called isc.org/community/RFCS/DNS. This is a very handy site to show you all the different RFCs for all the different DNS traffic that you might find. Now, whenever you look at a DNS packet, now this is the part where we're going to get into Wireshark, you'll run into a whole bunch of different information. So follow along with me as we get into Wireshark. Yay! Fun times. So first off, we have a DNS ID number, and this is going to associate the queries with the responses, because again, you're going to have packets that match up with each other. Yay, they're like bouncing balls, I guess. Super fun. So first off, we have this one, which is DNS query from me, and I'm looking for hack5.org. So I type in hack5.org into the search bar, as I usually would. Then down here, I see a transaction ID. This is 9329, so I can go down a little bit farther, see another query for 9329, and then we have a couple of responses with the same transaction ID. How very cool. Now, if you look at the packet header, I'm going to go back up to the first one that I had on here. There we go, and I have all my flags open. Cool. You notice that this runs under UDP, or User Datagram Protocol, which we have explained prior, and it's Domain Name System, DNS for short. Now, moving on, you're going to see a little thing in here called an OpCode. This is going to let you know what kind of query you're actually running on here. For me, I'm just doing a standard query. You also have Authoritative Answers if the response packet is from a name server. Next, underneath that is called TC, or Truncated for short, and this is going to tell you if the packet that you're sending is way too big of a big thing of data to actually fit in just one packet. Underneath there is called Recursion Desired, or RD for short. This means that the name of the server will support recursive queries. Z stands for reserved, and it'll tell you yes or no whether it is reserved or it's not. Usually it's just going to be set to all zeros, and in my case, it is set to all zeros, but this can also be used by the RCode field below it as an extension as well, if you do have the RCode available. Now, response code shows you any kind of different errors if you have response codes available, and then underneath that, you'll have a question count. So question count will show you the number of entries in the questions section. More on that in a bit. Now, answer count is the same thing for answers, and the name server count shows you the number of name server resource records found in the authority section, if available as well. Now, there's still a little bit more available in here too, so I'll move on a little bit farther down. Additional records counts shows you the number of other resource records in the additional info section. Questions has queries that will be sent to the DNS server. Answers will also answer any queries. Authority is the section that will have resource records for authoritative name servers used to continue the resolution process. And lastly is the additional information section, which may or may not exist on your specific packet query. That's a lot of different sections in one simple packet header, but there's a lot of information going on whenever you're sending out a DNS query. Now, DNS is also a question response format. As I said, more on this later. Now, similar to other protocols, of course, you're going to have matching packets. The client asks for an IP address from the DNS server, and then the server is going to send back information as a response, so they talk back and forth. In its simplest form, DNS only has two different packets. You'll see a few different resource record types whenever you look at one of these packets, including A from IPv4 host address, NS for a name server, TXT for a text string, and so on and so forth. More of this information can be found over on another handy website called iana.org. This is a great website. I know I keep bringing it up, but it's awesome. You can look under here and see all the different class codes for all the different DNS queries that you can send. So definitely check that out and do a little bit more research over there. Now, I'm going to explain a little bit more about DNS right after the break, but we're going to go thank our sponsor. How is your team communicating? Are they using a variety of email, IM, texting, cloud storage, and document sharing apps? HipChat puts everything in one place and is designed specifically for business. The solution, HipChat, is IM, video chat, document sharing, screen sharing, system updates, and my favorite, code sharing, integrated all into one simple platform. Email is way too slow, meetings get sidetracked all the time, and regular IMs don't work well for groups. HipChat keeps your team in sync, and it works from any device no matter where you are. The best part, HipChat integrates with the top developer tools like GitHub, Jira, Zendesk, and more. You can check out 57 services in all that HipChat works and plays nice with. HipChat brings your entire project and your team communications together. HipChat is easy to set up, it's fun to use, and it makes your team wildly productive. I use HipChat here in our offices specifically to share code with Darren for my Arduino builds on Hack5. You can get your team on the same page in seconds. I want you to try HipChat free with no credit card required. Visit hipchat.com/HakTip, sign up, click on the Start Chatting button, and then invite a few team members and try it for free for 30 days. Remember, that's hipchat.com/HakTip, and for the first 100 signups, HipChat is going to extend their 30-day free trial to 90 days. HipChat, your team, your project in sync instantly. We're back! Now for some more info on recursion, which I mentioned earlier. Now this happens when a DNS server acts like a client to further on the packet in order to find an IP address of an outside site, like when you visit google.com or hack5.org. Under the Recursion Desired label, it'll say do query recursively, and you'll see that in Wireshark when it happens. If the DNS server doesn't know which IP address belongs to a www site or whatever it's visiting, it'll continue on the packet to another DNS server. Depending on where the site server is located physically and on the interwebs, the query can travel through many different DNS servers until it actually finds the correct IP and it sends it back to you. This might explain why some sites load slower than others. Now lastly, let's talk a little bit about zones. DNS Hack5, for example, has a bunch of different DNS servers for all of our different stuff. So like we have hack5.org on a DNS server, and then we have our email on a different DNS server, and we might have HackShop on a DNS server and a copy of hack5.org, and so on and so forth. These servers are all called zones, and they are the authorities for the subdomains. A zone transfer might occur if a company like Hack5 or any other company wants to keep the domain redundant on another server. So there can be a full zone transfer or an incremental zone transfer, either meaning the entire zone is transferred or just a part of it. Zone transfers run on TCP over UDP with DNS because of the size of the packet. That's a lot of data moving back and forth, so they need it to be reliable. Luckily, TCP ends up being more reliable, so it uses TCP. Now in Wireshark, this would be seen under the type. So usually under type, you'll see something different, but in this case, you would either see AFXR for a full zone transfer. Now let me know what you think of all this crazy information about DNS. I know it's a little bit more complicated, but again, this is an upper layer protocol. Now send me a comment below or email us tips@hack5.org, and be sure to check out our sister show Hack5 for more great stuff just like this. I'll be there reminding you to trust your Technolust. Are you